Okay, for this question, diagram 1 shows a regular pentagon. There we go, 1, 2, 3, 4, 5. A, B, C, D, E inscribed in a circle of radius 1.5 centimeters and center O. Explain why AOB is 72 degrees. AOB. Now remember, we've got one triangle here, one here, one here, one here, 1, 2, 3, 4, 5. So 360 degrees divided by 5, and that's why. So what we're going to do, AOB is going to equal to 360 divided by 5, and that makes it 72. Here we are, that's been done. The second part is telling us to calculate the area of the pentagon ABCDE. This full area. I'm going to calculate the area of one triangle, and then we're going to take that area, we're going to multiply by 5 because there's 5 of those. Okay. Just trying to bring my calculator in here. So the area of the triangle we're looking at is part B, triangle AOB. To find its area, we say half AB sine C. So half times, I'm saying that this is A, this is B, and this is sine of the angle, 72 degrees. So half A, 1.5, which is the diameter, the radius, 1.5, then sine of 72 degrees. And check the calculators in radian mode, degrees mode, that's fine. So 0.5 times 1.5 to the square times the sine of 72 degrees, and we're going to get this much. Okay, so this is coming to 1.0699388581. So we're going to take all of that, multiply by 5. Therefore, area of pentagon is going to equal to 5 times all of this. So let's take 5, multiply this, 5.349 something. Okay, and so we can say 5.35 centimeters square. Now that's the part A and part B of the question. Now for part C of the question, we're going to have to look at this diagram, and they're telling us here, diagram 2 shows a design for a new coin. This is a new coin, and the vertices of the regular pentagon A, B, C, D, E are joined by circular arcs 1, 2, 3, 4, 5. These are the arcs, and whose centers are opposite vertices. Alright, so there we go. Now for example, the arc AB has center D, so AB has center D. Right, this is, there we go, that's like a sector here. And then we need to explain why ADB is equal to ADB is 36 degrees. Okay, now let me just remind you, if you've got a circle, you should know that the angle at center is twice the angle at the circumference. We did find that this angle was 72 degrees in the beginning. There we go. Therefore, if this is ADB, so ADB is equal to 72 divided by 2, which is 36, and we need to explain that angle at center is twice angle at circumference. So this is how we explained it. Right, so the second part is telling us to show that the length of DA is approximately 2.85. Show that the length of DA is approximately 2.85. So this is DA. Now what I need to know, I need to find this angle here. Alright, so if this is 72, alright, I can take 360 degrees, okay, minus 72, and then you divide by 2, you're getting 144. So what we're saying, that this angle here is 144. So we have a triangle like this, and this is 144 degrees. This is basically 1.5, 1.5, and this is DA. We need to show that DA is approximately 2.85. Let's do that. So, sorry, this is the triangle I've drawn, and we need to show that DA is equal to 2.85. So how are we going to do this? We can do this by cosine law. So we're going to say DA to the square is equal to 1.5 to the square plus 1.5 to the square minus 2 times 1.5 to the square times the cos of 144 degrees. So alright, this is 4.5 minus 3.64 You remove the square, you're going to get square root on the other side. So let's do the square root of that. 2.85, and here we go, it's been proved. 2.85. And that's been proved. This is how we do it. Now for the other part, they want us to calculate the area of triangle DAB. So DAB, the area of this triangle. Remember that this is the triangle. So if we want to find its area, it's very easy. So area of triangle DAB, you can use the formula half AB sine C again. So half times 2.85 times the sine of 36 degrees. So let's do that. So 0.5 times 2.85 to the square times the sine of 36, and this is coming up to 2.3871 something. So we can say 2.39 centimeters square. Now they want us to calculate the area of the shaded segment. This shaded segment here. Sorry, here. Calculate the area of the shaded segment in diagram 2. So if this is our shaded segment, we're going to calculate the area of the whole sector. First of all, area of sector DAB or ADB. It's going to go to 36 divided by 360 times pi all square, pi and then 2.85 to the square. Therefore, area of shaded segment is equal to the sector minus the triangle, and the sector is what we found there. This is 1 over 10, so this is like pi over 10 into 2.85 to the square minus the area of the triangle, which was found to be 2.39. Let's say 2.3871 and so on. So that's in brackets. I've got 0.1 pi times 2.85 to the square, close brackets, and then take away the result that we found, and this is the answer, 0.164615. It does make sense to me because this is a very small area. It's my assumption anyway. Alright, so this is the fourth part. And finally they want us to calculate the area of the face A, B, C, D, E of the coin. So this is the coin. Now if you look at this coin, it's made up of 5 sectors. One here, one here, one here, and one here. So 1, 2, 3, 4, 5. So we've got sectors going like this, these are the sectors. I mean, I'm just going to take one of them. Now what we know that this is 36 degrees. Okay, and no, this is not 36, this is 72 degrees. Because remember that was the first sector here. So this is 72, alright. And we know that the radius is 1.5. So therefore the area of the coin is equal to 5 times these sectors. I mean the sector, let's say OAB. Alright, so 5 multiplied by 72 over 360 times pi r square. So that's the answer. Okay, so this is 9 over 4 pi. And that gives us something like 7.0685 and so on. So we can say 7.07 centimeters square. That's the coin. So here we are for this question. Take care. Not a very hard question, but it's quite a lot of calculation. And that's it.